Good evening. Are you all ready for some lightning talks? Wonderful. Well, I think we should just go ahead and get started. So our first lightning talk for the evening is Meredith and compiling blocking Python to non-blocking JavaScript. Take it away.
So, when my friend Ian and I were idealist students, we sat down and decided to make the world a better place, as you do, and we decided that the best way that two developers could make the world a better place would be to remove some JavaScript from it. The web is the greatest application distribution platform on Earth, and it is a stain on our profession that it currently takes 5 different programming languages and at least 3 frameworks to get anything done at all. All you should need to know is how to program. Ideally, you should know a nice, friendly, easy-to-read language that's not full of unpleasant surprises, so there was an obvious candidate. So we built a tool for building full-stack web apps with nothing but Python. We built an interface designer, so you could design what your app looks like visually. We let you run your code in Python on the client side and interact with like the text boxes, checkboxes, buttons on your page just as Python objects. We let you run Python server side. We have a built-in database with a pure Python API, all deployed to the cloud in one click. But today I want to talk about this client-side Python code. If you're going to drive the objects on your web page as Python objects, then you're going to have to run Python in the browser. And if you're going to run something in the browser, it's going to have to be JavaScript. Thankfully, there is this great open source project called Sculpt, which can compile Python to JavaScript. So you can write your application code in Python, and we can compile it to JavaScript so it runs in your users' browsers. So we can give Sculpt a Python object, and it will represent that with a JavaScript object. We can give it a Python function. It will generate a JavaScript function that your browser can run. But there is one problem. JavaScript, in its infinite wisdom, is 100% non-blocking. And if you're going to have to do something that's going to take some time, then you're going to need a callback. Here's some code you might write any day in Python. So get a row from the database. If it's not there, throw an error. Here's how you write that in JavaScript. I count 3 nested callbacks, and I am not exaggerating here. This was copied and pasted from the first page of the Postgres JavaScript API documentation. But we have a Python to JavaScript compiler, and it's open source, so why not try to turn this into this automatically? So we git clone and start exploring. It turns out that Sculpt has a classic compiler architecture based, unsurprisingly, on CPython. It's got a parser that takes Python code and produces a parse tree. By the way, these are the file names in the Sculpt source tree if you're interested. And then it turns this parse tree into an abstract syntax tree made up of things you probably recognize, variable assignments, function definitions, function calls, and so on. And then it's got a compiler that walks this tree and spits out JavaScript. So this compiler is the thing we're going to have to modify to support non-blocking execution. So the first thing we do is we invent a new JavaScript class that a function can return to say, I'm returning, but I'm not done yet, I'm just blocked. And we call that a suspension. And then we can modify the compiler so every time it sees a function call, it generates JavaScript like this. So it calls the function and it looks at the return value and sees, okay, well, is this a suspension? Because if it's a suspension, then we're blocking, and I'm going to have to suspend myself. So it saves all its local variables, it saves its temporaries, it saves its exception state, and it returns all of that in a new suspension from this function. And so our caller is going to recognize that we have suspended and that it's going to have to suspend as well, and so on, all the way back to the JavaScript runtime. And then when the operation is completed, so in this case, the database has come back with an answer, then we just resume the suspension. And this restores all the local variables, jumps back to the right point in the function, and resumes the original suspension, which restores its variables, jumps back to the right point in the function, and so on, until we can resume executing normally. And so this is how We turn simple blocking Python into non-blocking JavaScript, so you don't have to. This has obviously been a very simple overview. If you're interested, I urge you to check out sculpt.org. I'm one of the maintainers now, and we're always looking for new contributors. And if you're just fed up to the back teeth of this whole JavaScript thing and you want to build full-stack web apps in nothing but Python, please do come check us out at anvil.works. Thank you very much.
Great, thank you so much. Next up, we have Efron with Elements of Style.
Hi. Everybody hear me okay? Okay, so my presentation is called The Elements of Style, named after the Strunk and White book. Now, the question is, why do we care about style? We're programmers, right? Well, programming is writing to two audiences. The first audience is the computer. The second audience is other people. One of the most fundamental things that happens to any programmer is they open up their IDE, they look at a piece of code, they go, this is garbage, who wrote it? And then they wait, and then they go, oh God, it was me. We want to avoid this. People understanding code is the most important thing about code. Imagine that you have two pieces of code in your system. One of them works fine, well, for 6 months, and then it breaks, and when you look at it, you don't understand a single thing, and it takes you weeks to fix. The other one doesn't work the first time you try it, but you look at it, the problem is obvious, it's fixed, you move on. Which code is better, the one that worked or the one that didn't? In my opinion, it's the one that didn't because someone could understand it. So what is style? It's clarity, it's simplicity, and it's honesty. It's trying to write your words so that they're the exact right words, not just ones that are good enough. I think that with writing, you want to strive to make your code prose. It's not enough for it to be functional. You want it to communicate its intent as clearly as possible. If you can get across to your audience exactly what you mean, you don't need comments. So, what is clarity? It's composition, it's word choice. What do we mean by composition? A program is well composed when it is made of functions that tell a story. And it's poorly composed when it's just lines of code that manipulate bytes, that don't grasp onto the human brain that's reading the code. Well, how do you compose well? You make the unit of composition the function. Here's a term I call the PowerPoint principle. Every function you write should be simple enough that you can fit it on a single slide and explain it to your boss in under a minute. This is not easy, it's hard, but it pays off. How to compose one? You come up with a descriptive name, you ask yourself, what does this function do right now? And then you refactor until what the function does is expressed exactly by the name. That is, unless the purpose of the function changes and you need to rename the function and start over. So when do you compose a function? If a concept's not self-explanatory, if it would take multiple lines to express, if a concept's visually noisy, or if you even think to yourself, hey, should this be a function? Well, yeah, probably. So this isn't a big thing. Small concepts make great functions. Product instead of sum, or yield file lines to get rid of the noise of doing a new open every time. But you don't have to go crazy in Java-y. If your concept's self-explanatory, don't build a function. So rules for functions, which I stole from clean code. Functions should be short. No, really, they should be really short. They should do as few things as possible, and they should not have side effects. And they should do, most importantly, exactly what they say they do. I know this sounds trivial, and I'm harping on it, and I'm being kind of a jerk about it, but it is hugely important. If your functions tell a story, people think in stories, and they can easily parse what you're looking at. What does this function do? So let's apply the rules of composition. Suppose we write a function that's trying to find a copied region in an image. What should we name it? Is copy paste image forgery? Does this function here, does this tell if something is a copy paste forgery? Maybe. I mean, when you read it after a while, it seems to be telling you, seems to be doing some import or something. What about this function? Does this test an image for forgery? Even if you don't know what any of these subfunctions do, it's pretty obvious. You import an image, you separate the image, you assign the blocks to the buckets, you process the buckets for similar blocks, and you see if there's any of them. That almost reads like a sentence. An English sentence, or a paragraph at best, or at worst, is what a function should read like. But there's one problem here. We've got this settings dictionary. We don't see it here, which means there's got to be a side effect. Where does it happen? In this subfunction. This is what this looks like. Do we understand what this does? Is it immediately obvious? Not really. But what if it looked like this? What does this function do? If it's grayscale, it scales it to an 8-bit integer. If it's RGB, it converts it to grayscale. Am I going way over?
That's 5 minutes.
Yeah.
I have to cut you off.
Well, now I just sound like a jerk the whole time because I'm trying to do a thing, and you can go higher and greater, but thank you for listening to me.
Thank you so much. Next up, we have Maria with refactoring lengthy bits of code.
Maybe we should make it refactoring long talks. Sorry. Now I'm going to go over because that's destiny. So there's a great organization called Software Carpentry that goes to universities and teaches scientists how to write better programs, how to be better programmers. And they have a tenet that they like to have their instructors be recent learners. And the reason for this is because not only are they going to reinforce what they've learned, but they are closer to where the learners are. They understand more about where they're going to get stuck, where they're going to get confused. And this kind of came home to me a little recently when I was trying to teach somebody about refactoring. And the problems are sort of the same whether you're an expert or whether you're just starting out. When you're writing code, when you're trying to figure out a problem, you write a bunch of code and you play around with it, and eventually you come up with something that works, but it's messy. It's got lots of stuff in it that probably doesn't belong there, and it's too long. And when you've been programming for a while, you look at this code and you say, oh, yes, should probably move this over there and pull this out into a function. And the beginners look at you and are like, where did that come from? How did you know that? And so this is my attempt to sort of download what's going on in my brain when I look at that code and say, oh yeah, you should pull this out over here. So hopefully it's helpful to other people. So step one is not going on in my brain. Step one is what you should always do. And of course, we're talking about lengthy code, so it does a lot. It's hard to test, but you should be able to come up with some sort of test that makes sure that most of what's supposed to be happening in this function is happening, so that you can go in and refactor it without breaking it. And step two, I would say, is to write out or say out loud what is happening in the function. Sometimes just saying out loud or writing down in English what's happening helps you understand how things should be structured a little bit better. So this is sort of a random summary of some code that I wrote a while ago that desperately needed to be refactored. And this often leads to this question. So step three, I would say, would be to write an outline, a sort of old-fashioned outline, points about what's going on in the code. And when you form the code in this manner, you start to see where your organizational flaws are. So step four, noticing that the outline might not make sense, playing around with it, and coming up with something that looks more reasonable. And it feels easier, especially as a beginner, to do this with something that's not actual code with all the extraneous stuff that goes along with it, just what am I doing, very short bullet points. Once you have that, your main bullet points can be your new functions. And everything that's in your old giant function can then go into those functions that are now your new steps. And then you can write a test for each of those new functions. And that's anyway how I refactor code. So I hope that's helpful to somebody.
Thank you so much. Next up, we've got Eric with Getting Things Unguilty.
Thank you very much. In code, as in life, there is always more to do than can be done, right? And this leads to what I call open source guilt. For a period of years, I was repulsed in my very gut every time I thought about the stack of PRs in my various open source projects. And as they stacked higher and higher, I felt even worse because I became even less likely to look at them, and they would never get shorter, and it was just making the problem worse, and around we went. Tell me if you feel me. All right. So I had to come to peace with this fact that there's always going to be more to review than can be reviewed, always more to do than can be done. And so I was left with only 3 alternatives. Lower my standards, and probably still never catch up. Never sleep, always a good option. Or just choose to do the most important thing at any one time. So then you can ask, what is the most important thing and how do I figure this out? Well, about 6 years ago, I was working in the office and my coworker Chris came by with a stack of these books, said getting things done on them, and he was giving them away. I said, sure, I'll take a free book, why not? And of course, I put it on my bookshelf for 6 years. I don't need some starchy business guy in a business book in a suit telling me an overcomplicated way to run my life. I mean, I'm a free spirit creative, right? So I chose instead to spend several years feeling guilty as these thoughts nagged and cycled through my heads. When I'm doing something, they'd be saying, shouldn't you be doing this project over here? Look at the pull requests over here. These people are asking for your support and help. When I finally cracked the book, I actually found a minimum viable system inside for getting that nagging to stop. Today, I have almost no open source guilt. I'm more responsive, ask any of my contributors, and I've been at Inbox Zero both personally and professionally for a year, and it's easy. So, I only got 5 minutes here, guys. So, I prepared for you a 1-slide version of this book. Brace yourself. So, this is simple. We're programmers, we can handle a couple of ifs, and there's only a couple of ifs in this tree. So now when you're doing one thing and a nagging thought says, maybe you should be doing this other thing, you write it down. You write it down on a card and put it in a bucket. Write it down in a file, stick it in a folder. Get it out of your head. Once you get it out of your head will know it can stop going around and around and rehearsing, trying to remember it. It knows it's taken care of. Then, once a day, put your accumulated bucket through this diagram, through this flow chart. I don't have time to go through this whole thing. Read the book, good book, entertaining stuff. Like most business books, it says the same thing over and over again. But here's the best part, the 2-minute rule. In my house, I have a staircase. At the top of the staircase is a filing cabinet, which is a stupid place for a filing cabinet. So the stairs become the filing cabinet. And every time I go by the stairs, I see that stuff stacked on the stairs. I see the papers stacked up, and I think, I'm a terrible, futile person and don't deserve to have clean stairs, and I certainly can't program. So the 2-minute rule is, don't even take the time to clean off the stairs on a card. It's going to take less than 2 minutes, so do it right now. Do it right now. Go up the stairs, file that stuff. It's totally easy. I took an early middle branch up there. And then I'll pass the stairs and I say, look, I have clean stairs. I'm a productive person. I can get things done. I'm in control of my own life. And that gives me a little psychological boost to move on to maybe doing something a little bit harder, like opening up the pull request tree and just reading the titles. This 2-minute rule, the best part of this is going to deal with 80% of your email, which you should also shove through this diagram, and it will assuage 80% of your guilt. The leaves of this diagram are things like have a reference system that you trust, files and folders, or Ulysses, or a personal wiki or something. Have a system that can defer things for a week so you don't even have to think about them. Have a someday list of things you're not really committed to, but maybe you want to think about once a week. Have a next list of, I have 130 things on my next list, which are anything that I could conceivably start doing today. And have a calendar for appointments. And then, the other most important thing about this is have a weekly time or periodic time when you review stuff. And you logarithmically move stuff up this tree. You take stuff from the big someday list and put it in the smaller next list. Then daily, you look at the smaller next list and promote some things to do today. And then you have few enough to linearly scan through all day. So you're not just continually linear scanning a big thing. You've got this lovely log tree so you can do your life in log n. That's how it works. So this is how I handle everything in my life now. My open source requests get batched, and every week I put them through this stuff. I put the rest into my system as priorities allow, and I do the 2-minute things immediately. And sure, some things are still dreadful, and I don't get to them for a month, but now I don't feel guilty about it. I highly recommend it. Go read the book. I don't forget things anymore, and neither will you have to. Thank you.
That was so efficient that you ended with literally 1 second to spare. Well done. All right, next up, we have Meggie with using slots for more opinionated objects.
Thank you. So I'm going to be talking about dunder slots today. Quick intro. I love magic methods and special attributes and all that good stuff. In fact, we named a room after it at my work, and it makes me so happy every day. And it's also a Harry Potter pun, I guess. Last year at PyCon, it was my first year here. And this was kind of me at a lot of talks. I was like, what is this dunder slots thing? Thank you, one Zoolander fan. Okay. What is this dunder slots thing? I want to know about it, and I don't know if I want to use it, but maybe I will once I figure out what it is. So I did some research, and so that's why I'm going to talk to you. So first, dunder slots begins with dictionaries in Python. And I'm going to be mainly discussing Python 2.7 dictionaries, but I'll address the other ones if I have time. And so dictionaries are very fast, right? Constant time access, but they're somewhat heavy. So here's a good example, and I know it's different in Python 3, and my world is very quickly becoming a Python 3 world, but dictionaries are somewhat wasteful in terms of their use of space. So here we have some cat facts. They're not filling up all the memory that they're sort of taking up. So you have to hash keys, store hash key value pairs, provide direct access, which is awesome, but you have this associative array. Dictionaries in Python less than 3.6 have empty slots. All right, so dunder slots is about objects. So how does this relate to objects? Well, as you might know or have heard, objects under the hood store their attributes in dictionaries because dictionaries are awesome. And so here we have a cat object. It's got one attribute, fur color. I can instantiate my cat, Salem the cat, my hypothetical black cat, and I can add an instance attribute whenever I want, right? Yay, instance attributes. And there it is in that dunder dict under the hood. That's how Python is keeping track of what those attributes are. When is this not cool? Well, sometimes it's like living in a mansion with only a sleeping bag, which if you're from San Francisco would be totally not at all familiar to you, but yeah, so it's a little wasteful. So enter dunder slots. So if we instead define what our attributes are going to be, so in this case I'm being more specific about my cat class, it's just a fur cat class. I'm just going to store data about fur, color. And so, I can make a fur cat. I can pass in that fur color. If I try to add favorite hobby, I get an attribute error. Oh, no, not oh, no. It's worth it. I don't need that attribute. I've defined that fur cat class to just hold that one piece of data. So why should you use dunder slots when you don't want to internally store instance attributes as a dictionary? When do you not want to do that? When you know that your object will only need a certain set of attributes and no more than that in its lifetime. So don't prematurely optimize everything that you read about dunder slots. Lots of great talks that I saw today that talk about dunder slots. This only makes sense to do if you have thousands of instances, and it's fun to kind of watch, benchmark or use time it or, watch it kind of make sense for you. What about Python 3.6? The Python 3.6 dictionary more efficiently uses space and awesome, maintains order, that's so cool. But dunder slots is still relevant. So I'm paraphrasing Brandon Rhodes after his talk today. Raise your hand if you were there. Yeah, so lots of great stuff. It is still relevant. I'd love to discuss, but I don't have time. And then in 3.6, Aaron Hall did a great talk today on this exact topic, and I had no idea that he was talking about that. Otherwise, I probably would have chosen a different topic. But wonderful factoids, including that even if you used slots in 3.6, it's still 4 times as fast. So that's cool. So thank you. I don't know how much more time I have left, but this is me. I teach Python and so much more at a coding bootcamp in San Francisco called Hackbright. We teach women how to code. Raise your hand if you're a Hackbright alum. Yeah, okay, I see one. Great. That's fine. There are a lot of them here, but that's my email. If you want to mentor a student, if you want to educate, if you want to be a student at Hackbright, women, that's for you. Or if you're hiring Python devs, definitely send me an email. And thank you very much.
Thank you. Next up, we've got Travis with crowd computing. Thank you for that lightning typing. Next up, we have Alan with physical modeling in Python. Take it away.
Hello, hello. I'm Alan Downey. I teach at Olin College. The very short version of this talk is I'm developing a new class and a textbook teaching physical modeling using Python, and I'm looking for suggestions and ideas. Most of you are probably not teaching engineering. Most of you probably don't care about this very much. I'm going to try to convince you to care just a little bit. With this number, which is that about 50% of the people who start an undergraduate program in engineering do not finish an undergraduate program in engineering. A big part of the reason is the science and math death march, which is for about 2 years, they don't get to do anything that resembles engineering, and a lot of people who would be great engineers never make it through this stage of the pipeline. So a big part of what I'm trying to do is fix that freshman physics experience, and part of that is getting rid of toy things like frictionless planes and no air resistance. If you really want to do physical modeling, you have to do all of these things. You have to be able to identify the system and the questions you're trying to answer, make modeling decisions, run analysis, run simulations, and then use those results to predict something, explain why the world is the way it is, and design things. You need to validate, and you always need to iterate this process. But in traditional engineering, the only part of this process that you do is to run analysis of models that are chosen and designed for you, so you never learn to do those other things. The good part is that we have a class that we developed where we do all of these things. Students practice every stage of this process, and it's a great class. I love it, but it's currently in MATLAB, which is kind of a good thing in the sense that that is still a valuable job skill in a lot of environments, but it's not a great first language. We're teaching this to people who have never programmed before, and it attaches students in a way to expensive software that we don't want to do. So, starting this fall, we're going to do the whole thing in Python, which is great. I think it's a huge opportunity. Thank you. I'm super excited about it. Most of what we want the students to use is they will be able to solve differential equations numerically. They will be able to do root finding. They will be able to do optimization. The kinds of systems that they're going to work with, I'll tell you in a second. I'm going to be wrapping all of this up in a module, which gives me the ability to hide what the students don't care about yet and make good error messages and customize things. I'm also thinking about using Pint so that everything has units attached to it, so that their first experience with computation, you always have the right dimensions and you don't crash Mars rovers. What they're going to be working with mostly are things that vary in time, things that change, either discrete things like population models, first order systems like thermodynamics, chemical dynamics, and then mechanical systems. So projectiles, rigid bodies, hinges, rotation, friction, air resistance, any kinds of systems like that. I'm looking for examples and project ideas and data sets and techniques and libraries that we should use, and just looking for conversations with anybody who wants to talk to me about this project. I'm going to be working on it this summer. Here are 4 ways to get in touch with me, and I just would love to talk to you. Thank you.
Thank you so much. Next up, we have Luciano with Time is Money, Really?
So recently I learned that the only guy that was not a US president that shows up in a dollar bill is this guy. And apparently he is the guy who invented the phrase, or he popularized the phrase, time is money. But is time really money? And this talk is about, I'm going to basically quote a small speech by this person. Antônio Cândido was a great professor of literature in Brazil who died last week. I was fortunate enough to meet him in a family context because he was the uncle of my wife. And so now I'm going to quote him. I think one of the most sinister things in the history of Western civilization is the famous saying attributed to Benjamin Franklin, time is money. This is a monstrosity. Time is not money. Time is the fabric of our life. It is this minute that is passing. In 10 minutes, I'm older. In 20 minutes, I'm closer to death. Therefore, I am entitled to this time. This time belongs to my affections. It is to love the woman I have chosen, to be loved by her, to spend time with my friends, to read Machado de Assis. That is time. And precisely the struggle for the cultivation of the working people, us, is the struggle for the conquest of time as a universe of self-realization. The struggle for social justice begins with a claim of time, I want to take advantage of my time so that I humanize myself. So you found time to come to PyCon, and this is awesome. Now go home and find time for yourself, your loved ones, your community. Join or create a users group or a PyLadies chapter in your hometown. Set up a hackerspace where we build stuff to learn, to have fun, and to express ourselves. Thank you.
Thank you so much. Next up, we have Cynthia giving us PyCon, a high schooler's perspective.
Good evening, everyone. My name is Cynthia Lin, and today I'll be talking about my experiences here at PyCon as a high school student. For context, I'm currently 15 years old, and I'm in my second year of high school. I've used computers since I was 5, but I only started programming a few years ago when I was introduced to Scratch. In my 3 years as a programmer, I've learned how to develop web applications, games, bots, and more with Python, JavaScript, PHP, MySQL, and MATLAB. You might ask, how exactly did I end up here attending PyCon with my parents supervising me? Last year, I decided to participate in Google Coded, a competition for high school students, encouraging them to contribute to open source projects. During GCI, I chose to work with Zulip, an organization developing a powerful open source group chat application. After I was introduced as a finalist for my contributions to Zulip, I continued contributing to Zulip, and this spring, I was invited to PyCon to participate in the development sprints as a core contributor to Zulip. After making several complicated schedule arrangements with my school administrators to avoid conflicts with final exams, I'm here at PyCon as a proud representative as Zulip. This is my first PyCon and my first tech conference. My perspectives are unusual in a few ways. Specifically, I'm going to talk about my perspectives on industry, and identity, and learning. About industry, I'm not here to look for job or career offers. Instead, I came to PyCon to learn from others and to teach others. That seems surprising to some people. While I was visiting the booths in the expo hall, I was constantly approached by booth sponsors asking if I was interested in working for the company. I told most of them that if they did, they would be practicing child labor. After realizing my age, most of these corporate-minded sponsors dropped their interest in me as an individual. Just seconds ago, we had been having a thoughtful conversation about the company and their products, but now something has shifted in their tone. I felt like I was no longer being recognized as a proficient programmer, but a beginner to Python and a child instead. And in addition, if I asked them if they offered summer internships for high school students, most of these companies stated that they were looking for individuals with more industry experience. And well, in these cases, I ended up walking away with a few more free, nice items, but I had empty thoughts. So in some of these cases, the sponsors actually grew more interest in me as a young developer with experiencing participating in Google Coding and working with Zulip. To those companies that recognize my worth as a potential programmer despite my young age, I can't thank you enough for making me feel more welcome at PyCon, and I look forward to working with you in the future. Yeah, my perspective on my career reflects my unusual identity. I'm a representative of several minorities in the programming community. Not only am I under the age limit for obtaining a driver's license in my home state, but I identify as a female, person of color, and a member of the LGBT+ community. For the most part, regardless of all that, People have treated me respectfully and in some cases even made me feel more welcome by asking me about my projects and what I'm learning. Assuming I am a programmer makes me feel accepted, and having a real engaging conversation with me about software engineering makes me feel welcome. And finally, learning. It's really fulfilling to get to talk with others about Python and computer science. My first reaction to seeing the size of PyCon was, wow, because I've never seen so many people in one place who are interested in programming. And not only have I learned more about Python by attending the talks and learning to talk with other people about programming, but I've also passed on knowledge by introducing others to Zulip at Zulip's Excel Hall booth and volunteering as a teacher's assistant at the Young Coders event this morning. After learning so much from the talks, it felt very satisfying to be able to pass on the knowledge to others, especially the younger generation. Thus, I've really enjoyed PyCon so far, with only a small few blemishes on my positive memories. I appreciate Python much, much more than before I came here Friday, not only because of what I learned was possible to make with Python, but the great community that supports it. I think the main message that I've learned from my experiences at PyCon is that everyone has something to learn, but everyone also has something to teach because everyone has different past experiences. So I ask that you be more considerate and understanding of the individuals around you, no matter they're male, female, old or young, corporate-minded, or pleasure-seeking, experienced or familiar with Python or some other contrast. It's important that we treat everyone at PyCon with a sense of respect and consideration, as we are all here due to our common interest in encouraging the future development and success of the Python programming language. Thank you for listening. I hope you enjoy the rest of PyCon.
Thank you so much. Next up, we have David with Python Fire command line interfaces generated automatically.
Hi, everyone. I'm David Bieber. Yes, Bieber. My Twitter handle is Bieber. And this is a talk about Python Fire, a library for generating command line interfaces automatically. With Fire, you can turn any Python program or any Python component into a command line interface with a single call to the Fire function. You call Fire in a program, and it turns that program into a CLI, or you call Fire on a specific component, and it will turn that specific Python component into a CLI. Since we can do this with any program, let's take a look at a simple example with a Hello World program. We have a single function here, hello, that takes one argument, name, which defaults to world. How do we turn this into a CLI with Fire? We import Fire, which we install from pip with pip install Fire. And then if name equals main, we call the Fire function on hello. Saving this file as hello and adding the appropriate shebang, we can now come over to the right side in bash and use this as a CLI. If we run hello, it'll use the default argument and say hello world. We can say hello at Bieber, or we can use flag syntax to set name to PyCon and say hello PyCon. Hello PyCon, come on. Thank you. So in this little example, we've seen that we can pip install Fire, import Fire, and call Fire on a function to turn that function into a CLI. But as you know, we're not limited to calling Fire on functions. We can call Fire with absolutely anything. Any Python component will work. So in this example, we turn this little calculator class into a command line interface by calling Fire on calculator. Calculator has these two methods, add and multiply. So if we save this Python file as calc and add the appropriate shebang, now we can run from bash calc add 1, 2, and it will give us the appropriate sum 3, or calc multiply 3, 4, and it will give us the product 12. Running calc without any args will tell us how we can use this command line tool at the prompt. So what exactly happens when we call Fire? Well, Fire takes the component it's given and it starts consuming command line arguments, using them to do different things depending on what the component is. It'll instantiate a class if the component is a class. It'll call a function if the component is a function, or it'll get a member or a property if the component is a dict or an object or something with members or properties. And this repeats, these actions repeat consuming arguments until you're left with a component, and this component is serialized in a human-readable way. As a concrete example, when we called Fire on the calculator class, what actually happened? Well, the component started as the calculator class, and our arguments were add, 1, and 2. We instantiated that class. Fire instantiated the calculator class, and that didn't take any arguments. So now we have a calculator object. we got the add member of that object, so now we have the add method, and then that gets called with the remaining arguments, 1 and 2. So now we have the number 3. There are no arguments left, no more actions to take, and so the result, 3, is serialized in a human-readable way, which is to say, it prints out 3. So this is a really general procedure, which means you can call fire on absolutely any Python anything. Call it with a class, an object, a function, a module, a dict, a list, a string, whatever you want. It'll turn it into a command line interface. You can also call fire with no arguments at all, and it will take your entire module, your current state, or the current context when fire is called, and it will turn that into a command line interface, which makes fire a really useful tool for your everyday development and debugging workflow. Take any Python program at all, add if name equals main, fire.fire to it, and now you can start using any part of that program from the command line. Fire also comes with this wonderful interactive mode that makes Fire a great tool for your everyday debugging and development experience, which I would tell you about if this talk were any longer. It looks like this. Now, as you've seen, you can call Fire on any Python component, and that includes Python objects that you didn't write yourself. And this means that Fire is a good tool for exploring third-party modules. As an example, we'll take the Python imaging library, and I'm going to write a 3-line program. From the Python imaging library, I import image, I import fire, and I call fire on the image class. I save this as imagefire.py, adding the appropriate shebang, and I download a picture of a giraffe. Using my 3-line Python program, I can now run this command. Imagefire, open the giraffe, convert it to grayscale, resize it to be 100 by 100, and save it as giraffeout.png. Using Fire, this single one-line command gives me a tiny little giraffe, and this demonstrates how Fire is a good tool for exploring third-party modules. Thank you. For additional resources, Fire is open source on GitHub. We have a Python Fire guide where you can see lots of examples, and I encourage you to try it yourself with any Python program at all. Simply pip install Fire. Thank you very much.
So we have a slight off by 1 error up here. What we are going to do next is we have several different conferences that are going to give you a quick pitch on why you should go to their fair cities and see their conference. And if all of the conference organizers want to come and line up on this side, I know I told you this side, but I was wrong. So this side. I'm going to just talk to you for a moment about the PyLadies auction, which is up next, and which you should consider attending and bidding on all of the amazing PyLadies items. The money from the PyLadies auction goes to support scholarship funds to help PyLadies and other programmers attend conferences like this. So every bid that you make at the PyLadies auction goes to a really good cause. And you'll be able to go to that as soon as we go through a couple of conferences. All right, go for it.
So hello, PyCon. I only have 60 seconds, and by now I think I have only 50. So, well, we are going to have a big conference this summer in Europe, and you are all invited. We are going to have 5 amazing keynotes, 5 days of Italian food, more than 7 trucks per day, and amazing cities to visit. So the community will be also there, so I hope to see you there. Thank you.
Hello, everyone. I'm here to talk to you about DjangoCon. So DjangoCon US 2017 is in Spokane, Washington. From August 13th through the 18th, we have 6 days. We have 1 day of tutorials, 3 days of talks, and 2 days of sprints. The talk list, the list of the actual talks that will be there, was just released, I believe, yesterday. So if you go to the 2017 DjangoCon.us site, click on the news section, you'll be able to find the list of talks. The detailed schedule should be out soon. We also have childcare available at the conference and a lot of other things that are wonderful. So For those of you here in the Pacific Northwest, this year DjangoCon is in Spokane, so it's not that far. So I hope to see all of you in the near future. Thank you.
Oh no. Yeah. Oh, it's happening now. Hi, I'm Leanna, and I'm super excited that Open Source Bridge is just 1 month away. It's here in Portland, Oregon from June 20th to 23rd, and it's sort of like the awesomeness of PyCon distilled into a more artisanally sized polyglot conference. We'll have Python talks as well as talks on all kinds of open source topics. So if you like weird hacks, kind people, caring about things, being enthusiastic, or Portland, you should totally come. Open Source Bridge is tied with PyCon for my favorite conference ever, and I can't wait to go again this year. Hope to see you there.
Hello, everyone. Is everyone having fun in PyCon 2017? Whoa! So then you have to go to PyCon Spain, okay? Oh, wait, the slide. Yeah, there we go. So you're going to have more amazing speakers, more talk, amazing food. It's going to be with amazing Spanish hospitality, amazing weather, and the best of all is in a UNESCO World Heritage Site, so you'll love the place. Come to do some tourism and stay for the PyCon. And the last thing I wanted to ask for your help is we are trying to give a big push on diversity this year. So if you are a woman or non-binary person, please submit your talks. The talks registration is open. And I hope to see you all this year eating and having beer for €1.
All right, next year PyCon will be in Ohio. PyOhio is not PyCon. It is in Columbus, Ohio from July 29th to 30th. We're celebrating our 10th anniversary. It's one of the longest general Python conferences. We've also videoed all our talks for the last 9 years, 7 of which are available on PyVideo. One of the things that makes PyOhio special is that PyOhio is actually free to attend, and we record all the talks. To paraphrase Brandon Rhodes from yesterday's opening talk, PyOhio wants to help bring the Python community to everyone, not just those who can pay a fee. We're very friendly to new speakers, and a number of PyCon speakers over the years have had their first talk at PyOhio. So it's free to attend. All you have to do is figure out a way to get there. If you want a t-shirt, we do ask for a $35 donation. And you have to register by July 1st. And we'd love to see your talk proposal, but you got to get it in this week, so start writing it. They're due May 25th. All right, so I want you to, since there's been audience participation, I want you all to repeat after me, okay? Hi-ho, hi-ho. It's off to PyOhio we go. All right, see you there.
Whoa. Who was there? Pi Bay. Yeah? Woohoo. Woo. Our second weekend of August is when we're going to be having our second annual regional conference in San Francisco. And last year, we had 4 tracks, 40 talks, 400 people. 96% of them were from the Bay Area, and 25% of them were women. Woohoo! So what do people, when we did a post-conference survey, what people really loved was how intimate the conference was. And in fact, it was really fun for people to be able to continue to hang out with their friends that they met 2 weeks after and go out for coffee. So we would love to have more of you guys come out. And also, another thing that people really loved was how great the talks were. And so this year, and we have also heard people talked about how they got more skills and got jobs as a result of the conference. And we've also heard people told us that they've
changed the technical direction of the company as a result of going to the conference. So we wanted to see more of that. Call for proposals is coming up. It's going to end on June 10th, and we would love to see your talks. And also, we are going to be sprinting on our Django backend website just immediately after the conference. So go find Daniel if you're interested in sprinting and helping us make the conference a little bit better. Thank you so much.
Hey everyone, I am organizing the first ever Florida PyCon for later this year. This has been great research. It's going to be October 7th. It is the first Saturday in October, so if you want to come down for a Saturday and then spend your extra day going to the parks or going out to the Space Coast, be perfect. We're starting small this year and hoping to ramp up in future years. And it's really fun. We're sandwiched right in between Grace Hopper celebration, which is also taking place in Orlando, and Orlando Tech Week. You can find more information at flpy.org, and we will be opening up call for proposals later this summer.
I would like to invite you to PyCon DE. So it's a conference at the other side of the big pond. This will be in Karlsruhe, which is a very nice place in Germany. And typically the PyCon DE was held in German, but now we switched gears a little bit, and it will be in English, so it will be interesting for you, even if you don't understand German. The date will be the 25th to the 27th of October, and we have multiple tracks of talks. We're also planning on sprints. So Germany is a very nice place to be. Maybe when you're over there, you should consider coming to PyCon DE. Thank you.
All right, I've got another first. We are starting a new conference called PyCascades, which will be here in the Pacific Northwest. It will start in Vancouver, BC, in Canada, not the Vancouver just outside of the city. So book the right hotels. We're running it in January, 22nd, 23rd will be 2 days of talks. We'll have 1 day of sprints, and there will be a ski trip before. So mark your calendars, especially if you love the Pacific Northwest. And then we will, after that, move it down to Seattle and Portland and see where we go from there. Thanks.
Hi, I know you all need a good excuse for getting to the Caribbean on winter. So that's the reason why we're celebrating Pi Caribbean for the third time in Santo Domingo, Dominican Republic. This is the oldest and first city of America, and we have a lot of history, a lot of incredible things. And you will have the same things that make PyCon so special. You will have the high quality of talks. You will have, and we have had more than 30 talks, 3 and 4 tracks, and a lot of amazing, the same amazing community that you have here. If you need another excuse to go there, there's just one more thing. The temperature there, the whole year is around 28 Celsius, grade Celsius. So if you need another, just find me over there because I have plenty. Thank you.
I went to Pi Caribbean last year. It was pretty delightful. This is not a conference about Python. There's actually an entire conference about documentation. I'm a Pythonista. I'm one of the creators of this conference. We just had our 5th year in Portland. We had 400 people right down the street at the Crystal Ballroom, where y'all might have been at a PyCon event, talking about all sorts of things around software docs. So I would like to invite anyone who's interested in this. We have a European conference in Prague. We also will be back here in Portland at this very time of year next year, if you would like to come back to Portland for a slightly different conference. And we also have an online and worldwide community with meetups across the globe. So this is a PyCon-alike community that is all about documentation, that is spreading across the globe at a much smaller scale than Python, but I invite you to join us. So thank you.
Hi, my name is Shunsuke Yoshida. I came from Japan. I'm this year's PyCon JP chairman. The PyCon JP will open September 7 tutorial and 8 and 9 sessions and finish 10 sprint. The venue is Waseda University in Tokyo. We expect around 700 people come. Tokyo is a capital of Japan. It's a unique city, and unique and historical and very nice city. It's great opportunity of Japanese culture and nice, delicious food experience. We start selling the tickets next month, but talk and poster session proposal both accepting. Please submit. English and Japanese proposal both okay. We're looking forward to the seeing you there. Thank you.
Hi, everybody. I'm inviting you to the second one, PyCon Colombia. It will be next year on February. I want to mention that this year was the first one, and we got more than 200 people, so we were very excited about it. The next year, we want to have more than 350 people. So I'm inviting you guys to go there in Colombia. That is very nice place to go, take on vacation, go with your family, and enjoy Python as well. Thank you.
Hey everyone, my name is John. I'm one of the organizers of PyGotham, and we're coming back this year, October 6th through 8th. If you've never been there before, it's a general Python conference that takes place in New York City. We're expecting 60 talks and 600 attendees, and this is our very first year offering a Young Coders program. So hope to see you there.
Nice to meet you. In this case, there is no slide, just a t-shirt where you can find all the dates for the next conference of Python. If you're interested, I can tell you what's the next conference, in the world, of course, just that. I think I will try to create, for the Python Tour 2018, with the concours of the PSF. If you're interested, you need to add your event on python.org/events, and I will print them, okay? Thank you.
Thank you to all of our amazing Lightning Talk speakers. We will have a few more Lightning Talks tomorrow morning before the keynote. And that's it for this evening as far as Lightning Talks go. But the PyLadies auction, it sounds like, is already starting to heat up. So I would suggest heading over there.